Today we're going to go over lab safety. We mostly won't be dealing with chemicals, but we will go into the lab. Cool. So we just passed out the student contract. You need to read over this. Get your parents to sign it and bring it back as soon as possible. We will be having a test over this tomorrow. So make sure you read it and pay attention. So, lab safety. So, even though we're not going to be dealing with dangerous chemicals, it's important to know about lab safety. Whenever I was in college, does anyone know what acidic salt is?
No, sir.
An acid salt. Anyone ever seen The Mummy?
Yep.
Where there was pressurized acidic salt, and the salt, as soon as he opened it, it flew on and melted him. If you've seen that movie, first of all, acidic salt doesn't work like that. Acidic salt needs to mix with water before it becomes acidic. It's just a normal salt that whenever you dissolve in water, it produces a strong acid. So usually if you spill some acidic salt on you, there is some moisture in your skin, but it shouldn't immediately start dissolving as you can quickly get it off. However, so someone had spilt some acidic salt on a table in my college class, my college chemistry class. And whenever we walked in, one student went in, saw some powder on the table, and what do y'all do whenever you see something on your desk? You wipe it off. So she got it on her hand. So again, it needs to mix with water before it becomes dangerous. In order for it to become dangerous, so if you get on your skin, usually it'll start bubbling after a while, it'll dissolve into your the moisture in your skin. But later in the class, a few minutes after class started, she took her goggles, lifted them up, and rubbed her eye.
Oh my gosh.
Now there is water in your eye. And
Did she look like that?
it wasn't that bad because we followed safety protocols. So as soon as she rubbed her eye, it was a few seconds later that she started screaming in pain. Luckily, the professor immediately recognized the danger and went and grabbed her and put her under the eye wash.
He didn't even think. He probably just went.
Oh yes, if something gets in your eye and we have to use the eye wash, I will be assisting holding your head underwater.
Oh Lord. Someone got to, because I spent myself with any conditioner.
Need any 11th grade student, last name starting A through M, that needs a schedule change to come to the office at this time? 11th grade students need a schedule change, last names A through M, come to the office at this
Can I
time.
use this in like chemistry now, or organic
Yeah.
chemistry? Okay.
And Mariette, you don't have to have 2 copies if you don't need it.
Okay, great.
I like my classes. I ain't gonna switch out.
There's going to be this recorded online in case you can't leave. Alright. So, cornea damage by chemical splash without goggles. So, not only do you have to worry about that, you also can touch something and put it in your eye. So 90-95% of her vision was lost. But because the professor was so quick on getting her under the eye station, after about 2-3 months later, toward the end of the class, she had gained all but 20 or 30% of her vision back. So by acting quickly, she saved most of her vision in her eye. If you fail to do it quickly enough, you could permanently lose all vision in the eye. Have you ever had a water gun be blasted into your eye? Is it really easy to keep your eye open? No. Usually you're going to have to sit there and force your eyes open, and you're going to want as much water to go in it. Your natural tendency is going to be to keep your eye closed shut. So recognize safety equipment, including fire extinguisher, fire blanket, first aid kit, gas and electrical shutoff valves, emergency exits, eye wash, safety shower, and vent hood by identifying the piece of equipment, its location, and its function. First day in lab, I will point out everything, where it's located at. You also need to recognize what appropriate attire by identifying errors or suggesting remedies for a scenario or picture. So I will give an overview before lab, what we'll be doing, but you should have a general knowledge just in case there's something left over from a previous lab. Whenever we're saying we're having a lab day, so let's say we're going to be in the lab tomorrow. Do not walk into this classroom and immediately go into the lab. You need to come in here and wait for it to be dismissed. Also, I will have things laid out on the table. Another teacher might have something laid out on the table. Don't go in and play with it. You shouldn't start, so I will have toys maybe laid out. Don't pick up a toy and start playing with it. I know one time I specifically sat there and measured like a foot, and have everything spaced out, and someone comes over, picks it up, and have to remeasure it out. Sometimes I lay things out specifically for a reason. Follow all instructions, follow all instructions, both written and what I give you. Be sure to ask any questions that you don't understand, and do not conduct your own experiments. Do not play around in the lab. You will keep your backpacks in here. Do not take your backpack in there because you could trip over it. So no purses, backpacks, or unnecessary books in the lab. Know the use of and location of safety equipment. Know where the eye wash is. So if you're blinded, if for some reason I'm called out and you get a chemical in your eye, will you be able to find the eye wash blind? You probably never think about it, but you should always know where the eye wash is. I've worked in ultra dangerous labs with some of the most dangerous chemicals in the world. Every time you're doing something, you need to be able to close your eyes and point to the eye wash station. You need to be able to know where all the equipment is at all times. Always have it in the back of your mind. Again, we're not going to be dealing with any dangerous chemicals, but there is a small chance you might need to go use it. So goggles and aprons should be worn anytime heat, chemicals, or glassware are used. I do know that we will be heating up water and glass, so you will need to use aprons and goggles. Glass, whenever it explodes or shatters, turns into high velocity shrapnel that can pierce through your clothes and stab you. It can also go into your eye. Having glass go into your eye is very bad. One is transparent, which means they can't, if you have to be rushed to the emergency room, it's hard to find glass in your eye. It's hard to remove it, which means you might actually lose an eye. If we have to use the eye wash, you will need to use it for 15 or 20 minutes. Again, it is very hard to keep your eyes open for 15 or 20 minutes, but if you want to recover your vision, if you don't want to lose an eye, you need to force your eyes to stay open in the eye wash. Safety shower. If you get a chemical spilled on you, and it's a dangerous chemical, you need to go and stand under the shower and let it wash off. Get acid spilled on you. The acid isn't just going to magically stop burning you after a few minutes. You're going to have to sit there and stand under as long as possible until all that acid is washed away. Fire extinguisher. Have you ever used a fire extinguisher? So there's a safety pin. It's very easy. It looks like you ever seen a picture of a hand grenade? It's one of those pins. You pull it, and then you see that lever at the top. Point it at a safe direction, and always have it, and then you can press it. Fire extinguishers do not put out fire directly. It stars fire of oxygen. So if you should be pointing it toward the base of the fire or what's actually burning. So we have a massive column of fire. If you can imagine a bonfire with the flames going up, you don't want to be pointing it at the top of the fire. What you want to be doing is pointing it at the wood. So it'll starve the wood of oxygen, putting out the fire. First aid kit contains band-aids, burn cream, etc. Burn cream mostly deals with pain, has lidocaine in it. Very helpful because burns can be quite painful. It also has some other stuff like Neosporin, triple antibiotic, and things that can help prevent scarring. Burns often create nasty scars, and you can put burn cream on. It can help reduce scarring. Fire blanket. By the storage closet, used to put out small fires or for a person on fire. So if someone is catching on fire, their clothes catch on fire, you use a fire blanket, put it over them, smother out the oxygen. Usually you want to put it down and pat. Don't put it around someone's head and just immediately smother them. If their hair catches on fire, I should say you can throw it on the head. Just don't make sure they're still able to breathe. Exits, know where the exits are. If we need to evacuate, we will go down to the cafeteria exit. I'll get to fire drill center in a second. So how would you decide when to use a fire extinguisher, fire blanket, or shower to put someone out? Or put out a fire, I should say.
So you use the fire blanket when the small fire someone else is on fire.
Mm-hmm.
And then use the shower. I don't know.
Chemical, if it's a chemical fire, like acid gets on your clothing and acid catches it on fire, you want to use water then. Some chemicals, though, react with water and it'll make it worse. I will go over the safety precautions of what to do with every chemical, and if you don't know, you should ask, in case I fail to mention it. And fire extinguisher, if someone's on fire, would you spray them with a fire extinguisher? No, it starves oxygen. You would basically make them suffocate. No food, gums, or drinks in the lab. So some chemicals are safe to handle, but are highly poisonous. For example, this. Completely safe to put on your hand. It kills bacteria, but it's destroying a cell wall. We don't have cell walls, so it doesn't damage us. This is completely safe. However, if I were to ingest it, I'd poison myself. Actually, because of COVID, a lot of companies have accidentally started skimming on safety. Some hand sanitizers that have been going out in the last few months contain methanol. Do you know anything about alcohol production? Methanol and alcohol are closely related. Methanol is very similar to ethanol, the alcohol in beer and liquor. Methanol can cause you to get drunk, but one of the things it does is attack your eyes, and it's highly toxic. Whenever they produce alcohol, which a lot of hand sanitizer uses alcohol in it, you're supposed to remove all the methanol because a small amount will cause you to die. It's very lethal, and small amounts below the lethal deal causes permanent blindness. So some chemicals are safe to put on your skin, but if you accidentally ingest a small amount of it, it could kill you. A good example of this is like snake venom. So, or another example is snake venom. If I were to take a shot of snake venom with rattlesnake and drink it, what would happen? Nope. It passed through you. Snake venom is toxic, not poisonous. You could drink it, should be just fine, might have an upset stomach, but as long as there's no ulcers or cuts inside your stomach and your intestine system, you should be fine. If you have an ulcer, it can get into the bloodstream, but it's a toxin. has to be injected directly into your veins. So some chemicals are toxins, which means you have to wear gloves. Some are poisonous, which means it's safe to handle without gloves. But if you accidentally put it on your food and then eat it, you could die. So all accidents, no matter how minor, need to be reported. You cut yourself, tell me. Because some students, whenever I was in high school, we used to do blood test to students for a nice biology deal, where we take a drop of blood, we put it in. We don't do that now, but because of obvious reasons. But one person was unable to stop bleeding. They didn't produce enough platelets. They had a clotting disorder. So poked a little tiny hole, got a blood sample. We figured out that she was like AB or something. And then a few hours later, she goes to the nurse. I haven't stopped bleeding since second period. She did not know that she had a clotting disorder, or she didn't tell the teacher that and thought it would be okay just because it's a small prick. And there's also concerns of infection and stuff. You need to report all errors, so I can all injuries and spills, so that we can address it. In an emergency, get my name or come get me. There are going to be, we won't deal with it, but there might be some living specimens or non-living, such as there's a pig heart in the lab. Biology might dissect it. Our A&P might dissect it. Do not play with any living, even if it's deceased. Any organic material like that. Treat it with respect. It was a living thing at one point. If we have anything living in there, do not cause harm, shake, or damage for their specimens. Whenever we're done with lab, I say you are done. Do not immediately go to the classroom until you are dismissed. You need to have your lab set up clean first. If you're done clean, ask me to come check, and then I'll dismiss you to come back to the classroom. When everyone is at your table is ready to be dismissed, raise your hand and make sure you push in your chairs. Disposing of lab material. Do not take broken glass, throw it into the trash can. Glass is sharp. It will cut through that bag, and then all the contents of the trash bag will spill out onto the floor. We do not want Miss Bambi to have to try to handle broken glass on the floor, because you did that, you might end up cutting herself and seriously injuring herself. So we have a cardboard box. I will point it out where it's at. Broken glass should be thrown in there. Also, do not handle broken glass with your hands. It needs to be done with a broom. No horse playing. I'm very serious about the lab. If you are horse playing around in the lab, I will ban you from the lab for the rest of the year. And you will go to the ISS room during the period to work on, to do an alternative assignment. Basically, writing a long document stating what you think the lab was about, what you think you will have learned if you participated. I will make it as unpleasant as possible, really long and complicated, and that would be your alternative grade. So looking at the rules on the contract, wash your hands. So when you go in the lab, you're going to get dangerous chemicals on your hand probably. You might at least, or you might get some chemicals that you don't want, shouldn't stay on your hand all day. It's safe to touch for brief periods, but prolonged contact is bad. Wash your hands before leaving the lab. Fire drills. So this building is flame retardant. That doesn't mean that it's fireproof. What it means is that when this building catches on fire, the fire is going to slowly spread. If we're in the lab and they burn a cake, the whole school isn't going to catch up in fire in 5 minutes. Do not immediately evacuate the lab if a fire drill goes out. Make sure that it's in a safe, like if we're using a Bunsen burner and we have a flame going on. You do not want to leave the lab and let the room fill up with gas. You want to make sure, because we don't want gas being filled up in the room with a fire 2 classrooms over. So you will wait until until I dismiss you to go, and again we will go down by the cafeteria. Another thing, even if we're not in the lab, if a fire drill were to occur, you will not leave this room until I give you the say so. Unless there's imminent fire, like you see a bunch of smoke coming in from here, like you see smoke falling down, there's a ton of smoke, and you feel like your life is in danger, only then can you leave without my permission. Another thing, so we talked about this every year, but at the beginning of the year, what to do in case of a shooting. As you are aware, there's been several school shootings in America. One of the things they like to do is to go and first pull the fire alarm. Then they wait at the end of the hallway. A whole bunch of students come out, and then they up and fire. My policy is I'm going to go, have y'all line up behind me, I'm going to stick my head out, I'm going to let some other classes go first. I'm going to look and see if I see any smoke, and I'm going to wait about a minute or 2 before we leave. We'll see if it's safe to do so. If I see a ton of smoke, then I know there's a real fire, and we'll go immediately. But if I don't see anything, we'll go wait a little bit before I evacuate you. Goggles and aprons. We're going to wear a goggle and apron anytime we use glassware or anything hot. Contacts. Do you wear contacts?
No, sir.
In the event that you do ever happen to have contacts on, super glue. Super glue reacts with moisture to make it, that's the reason why it sticks. That's the reason why it's not stuck inside the bottle, and why if you open a bottle of super glue and close it, after a while it'll turn all solid. It reacts with moisture, which means if you touch your skin, it immediately hardens. But the vapors itself, if you ever use super glue, you might notice your eye irritating. It's because some of the super glue vapors, it's very volatile, will come up and stick to your eye and cause your eye to do it. Usually in small amounts, it's not that bad, but if you have contacts, it will super glue the contact to your eye. Some chemicals also can dissolve the contact into your eye and cause damage. Hair and clothing, no long sleeve jackets, roll it up. Hair needs to be tucked back if that's appropriate, which in your case it doesn't apply. Eye wash needs to be done for at least 20 minutes. Smelling and touching chemicals. So during my college speech class, I demonstrated electrolysis of water, taking H2O and splitting it up into hydrogen and oxygen. In order for that to work, you need an electrolyte. You need to make the water be able to conduct electricity. I use table salt, sodium chloride. And what happens is I also break sodium and chlorine and produce chlorine gas. Chlorine is highly poisonous. Whenever chlorine enters your lungs, it mixes with the water and produces hydrochloric acid. And how you're supposed to smell chemicals, you're supposed to walk from a distance. And I commented with this professor standing close to me, that you can smell chlorine being produced. She was curious what chlorine smelled like, so she put her nose over it and took a breath. It caused her lungs to immediately seize up and stop working for a few seconds, and she was starved of oxygen, and then started collapsing backward, almost falling down. Luckily, it only lasted a few seconds, but do note that it doesn't take much. It's very little chlorine. It's safe enough that I wasn't concerned about it. But if you put your nose over it, that's becomes a problem. You get a highly concentrated thing, which causes you to pass out and fall backward. Broken glass should be used. Shouldn't use your bare hands. Put it in cardboard box, not in a trash can. Electrical equipment. Have you ever been electrocuted?
Oh, yeah.
By what wattage?
I don't know. I tried an electric fence or something.
Were you able to let go?
Yeah.
Okay, so you should probably know that if you were to touch the main line right there, if you were to put a fork in there, chances are you are going to be stuck there. your entire muscles will start seizing up and you'll be locked into place. In fact, if you touch, it causes your muscles to contract. So when you contract your hand, it makes a fist. So if all your muscles were to be activated, you make a hard fist. So if you touch a wire, if you touch your with the tip of your fingers, you might close it and let go of the wire. But if you do it like this, it could cause your hand to seize up and you will be held there. You will sit there be completely paralyzed, looking at your hand burning, your skin charring as you sit there and constantly electrocuted. You will not be able to let go. So be mindful of electrical equipment. Do not pull things by the cord. Pull it by the end so you don't rip out the cord and touch some live wire and be stuck there. If you see someone else being electrocuted, don't go up and touch them because you could be electrocuted too. And another thing, electricity doesn't kill you unless it goes through your heart usually. Which means if you walk up, someone's being electrocuted, you walk up and touch them on the side, you can cause electricity to go through their heart, killing them immediately, and now you're in the same situation. Usually what we do is when I was in college, we had a safety stick. It was, I think one professor had a baseball bat. But usually we have like a yardstick. And what it's meant for, wood doesn't cut electricity, we go up and push them off. We never will go up and touch them. If you don't have a stick, the strategy is running, sprint, and a tackle. Because if you go up and try pushing, as soon as you touch him, you'll be electrocuted too. So if you need some momentum so that whenever you break the contact, force him to break it, you're not stuck there being electrocuted too. Chipped glassware. So the glass is tempered in such a way that doesn't break. How it does this is cooled in such a manner that all the glass molecules are in tension. It causes it very resistant to being shattered. However, if there is a single chip, a single crack, the entire safety of that glass is compromised, and if it's heated up, it'll just explode. Hot glassware. So glassware stays hot for a very long time. You can't tell if it's hot either. You heat up some glass, and you take it and move it over, and 10 minutes later, you forget that you heated it up, and you go and touch it, and you burn your hand. It really sucks to have second-degree burns, or even third-degree burns. Well, I think you'd only be able to get second degree. It sucks to have first or second-degree burns on your fingers. So if you heat up any glass, you can no longer touch it without tongs. Heating test tubes. Test tubes should be treated as if they're mini cannons or guns. Do not point them at yourself or anyone else. I've seen students go and heat up a test tube, and I tell them make sure not to point it to themselves, and then they turn it to their neighbor. Make sure mindful of where it's pointed. Treat it like a gun. Do not point it at yourself or anyone else. Never look down the tube. Alright, so what's wrong with this picture?
Everything.
Yes. One person isn't wearing goggles, one person is looking directly down a test tube. Untidy, spilling chemicals. Chemical spills, you need to address it.
The wires.
Yes, wire is all tangled up. What's wrong with this?
Students about to drink it.
See, I always get, even with two people, 50-50. Some people say that he's about to drink it. To me, it looks like he's smelling it, but it kind of does.
That's the wrong way to smell it, too.
Yes. If you want to smell it, you want to waft. Kind of looks like coffee, though, in a mug, beaker. But if you're smelling chemicals, make sure you keep it away from your face. Don't ever put chemicals toward your face because you immediately start reacting and bubbling. Some chemical reactions, you can sit there for an hour and does nothing. In a blink of an eye, it immediately starts bubbling and sprouting everywhere. Some chemicals have a delayed start. What's this student doing wrong?
The hair is not tied back.
Hair is not tied back. So hair, and especially sweaters, are a magnet to chemicals and filth. If you take your hair, it won't apply to you guys, but if you lean over a table and the hair drags onto the table, it will pick up all of the chemicals that are on the table and trap into the hair. Like I said, this acidic salt can mix with the moisture. So same thing with your long sleeve shirts. What's this person doing wrong?
Eating at the lab.
So you're going to no doubt touch the table. Table, you can put chemicals on your hand. Hand touches the apple, and then you eat it. Some chemicals are poisonous, even though they're safe to handle your hand. Like for example, hand sanitizer is perfectly fine, won't hurt you if you put it on your hand. If you drink it, it will poison you. What is this student doing wrong? Or these students?
It's hard to see it. Looking in the test tube and
He's not looking in the test tube. He's pointing away.
the other one. I can't really see what she's doing.
So he has a Bunsen burner, and he's trying to light it. His Bunsen burner is lighting up vertical,
Okay. Now
but they're dealing with glassware. They're about to heat up. They're about to start a fire and heat up some glassware. They're not wearing goggles.
Now I see it.
They need to wear goggles. That glass could explode, sending shrapnel into their eyes. All right, that's it. So tomorrow we will have a test. Have those safety contracts. Let me see. Oh,
Sir, I don't think I'll be in this class tomorrow. My entire schedule's about to change. My transcript finally came in from my other school. I'm apparently still a fifth grader.
so Kobe.
Yes, sir.
All right, and what's your name?
Dylan,
Dylan. All right,
they're putting me in.
Kobe, you haven't signed up to Google Classroom? Yes. And you're a new student, right? You're not in the system yet for me to send you an email, but you said you're still scheduled those days?
Wait, I don't even know my student.
It's your first name, last name at broadusisd.com. Password should be your lunch number at BISD.
You know Lil Dad, right?
Who?
Lil Dad?
Yes,
You know it's my uncle?
I did not.